July 4, 2012. Inside the main auditorium at CERN, a tension thicker than lead shielding fills the air. On screen, a graph peaks, a tiny bump against a sea of statistical noise, confirming a discovery decades in the making. The Higgs boson. Its mass clocks in at roughly 125 giga-electron volts. The room erupts in applause. Peter Higgs himself wipes away a tear. This particle was the final, critical keystone locking the standard model of particle physics into place. It was a monumental triumph, the culmination of a global, multi-generational effort to understand the fundamental architecture of reality. Yet, as the celebration echoed around the world, a quieter, more unsettling realization began to dawn in the minds of theoretical physicists. That number, 125 GeV, wasn't just a confirmation. It was a warning. When paired with the precisely measured mass of another fundamental particle, the top quark, it pointed to a terrifying possibility woven into the very fabric of existence. It suggested that our universe is a cosmic counterfeit. This isn't a metaphor. It's a direct mathematical implication of the physics we hold most dear. The idea hinges on the nature of the vacuum. In classical thought, a vacuum is simply empty space, a void. But in quantum field theory, the vacuum is a cauldron of roiling energy, the lowest possible energy state of all the quantum fields that permeate the cosmos. It is the absolute ground floor of reality, or it's supposed to be. The Higgs field, the very field that gives mass to elementary particles, has a potential energy shape, much like a landscape of hills and valleys. The universe, like a ball rolling across this landscape, will always seek the lowest possible point, the true vacuum, the state of maximum stability. The data from CERN, however, suggests our universe never made it to the bottom. Instead, it seems to be resting in a shallow dip, a small, precarious valley partway up the slope. This is what physicists call a cosmic precipice, a metastable state, or a false vacuum. To understand the gravity of this, imagine a dam holding back an ocean. Our universe is the placid village built in the valley below, thriving in the belief that the dam is eternal. But the dam has a microscopic structural flaw. For now, it holds, but the laws of physics themselves guarantee that eventually it must break. The energy difference between our false vacuum and the hypothetical true vacuum is that ocean. Our universe exists in a state of temporary equilibrium, a cosmic accident of stability. It's not fundamentally unshakably real. It's a phase, like ice is a phase of water. And just as ice can melt, our vacuum can decay. The standard model, our grand theory of almost everything, doesn't just allow for this instability. The measured masses of the Higgs and top quark actively point towards it. As detailed in a landmark 2013 paper in the Battazzo, Degrassi, Giudice, and others, these values plot our universe on a phase diagram right on the edge of metastability. A few percent difference in the top quark's mass, and we'd be safe. But the measurements from Fermilab's Tevatron and CERN's LHC are too precise. They place us squarely in the danger zone. This isn't a flaw in the theory, it's a feature, a chilling, existential feature. It implies that the universe contains a hidden poison, an inherent self-destruct mechanism. The very laws that allow for our existence, that give mass to the atoms in our bodies, are the same laws that write a potential termination clause into the cosmic contract. Everything we see, from the Andromeda galaxy hurtling towards us to the intricate dance of quantum mechanics in a silicon chip, is predicated on the Higgs field remaining in this specific fragile state. If it were to ever transition to its true, lower energy ground state, the consequences would be absolute. The fundamental constants of nature could change. The interactions between particles would be rewritten. The very possibility of complex structures like atoms and stars could be erased. We live, it seems, on borrowed time, in a universe that is fundamentally, structurally, a ticking time bomb. The only questions are, how long is the fuse, and what, if anything, could possibly light it? From that unsettling realization of a metastable universe emerges the terrifying mechanism of its potential demise. The trigger isn't a cosmic collision or an exploding star. It's a ghost in the machine of reality, a fundamental weirdness of the quantum world known as tunneling. In our everyday, classical world, if a ball is in a valley, it needs a powerful kick, a sufficient input of energy to get over the surrounding hills. It cannot simply decide to appear on the other side. But in the quantum realm, the rules are different. An alpha particle can escape the powerful nuclear forces binding it within an atomic nucleus without having the energy to do so. It tunnels through the energy barrier, an act that is classically impossible but quantum mechanically inevitable. This isn't a theoretical trick. It's a measurable phenomenon that underpins nuclear decay and even the fusion reactions that power our sun. And the same principle that allows a particle to escape a nucleus allows the universe itself to escape its false vacuum. At any moment, in any location, in the vast, empty expanse of space, the Higgs field can, through a purely random quantum fluctuation, tunnel through the energy barrier that separates our reality from the next. The result is the spontaneous nucleation of a bubble of true vacuum. This is the universe's ultimate phase transition. Think of a pot of supercooled water, chilled below freezing but remaining liquid because it lacks a nucleation point. The moment a single ice crystal forms, a chain reaction spreads rapidly, freezing the entire volume. The vacuum bubble is that first ice crystal. Once formed, its outer wall would expand in all directions at the speed of light. Not near the speed of light, but precisely it. This is not a shock wave traveling through space. It is space itself, along with its fundamental properties, being rewritten. There would be no warning. Because its boundary moves at the ultimate cosmic speed limit, no information about its approach could ever reach us. An astronomer observing a distant galaxy would see it vanish from their telescope at the exact same instant their telescope, and the Earth itself were engulfed. It would not be an explosion of fire and light. It would be a silent, instantaneous cessation of existence as we know it. Inside the bubble, the laws of physics are different. The value of the Higgs field would be orders of magnitude larger, as calculated in models based on the Standard Model. This would drastically alter the masses of fundamental particles. Electrons and quarks might become so heavy that they would instantly collapse into microscopic black holes. Or they might become massless, preventing the formation of atoms altogether. The intricate balance of forces, the strong nuclear, the weak nuclear, and the electromagnetic, would be shattered. The very basis for chemistry, for stars, for planets, for life, would be gone. It would be a universe rebooted to a new, alien operating system, one in which our kind of complexity is a fatal error. Now we must clarify what is established and what is speculation. The principles, quantum tunneling, the Higgs mechanism, and the measured particle masses are cornerstones of modern physics. The calculation that these values lead to a metastable vacuum is a direct, if startling, extrapolation of the Standard Model. The probability of such an event occurring in our observable universe is, according to most calculations, extraordinarily low. The predicted lifetime of our vacuum is many trillions upon trillions of years, far longer than the current age of the universe. However, this comes with a colossal caveat. These calculations assume that the Standard Model is the final word on physics all the way up to the highest energy scales, an assumption most physicists believe is false. New undiscovered physics like supersymmetry or extra dimensions could introduce new fields or particles that act as a stabilizing force, effectively repairing the dam and rendering our vacuum truly stable. We are living in a profound cosmic uncertainty.
We have measured the flaw in our reality's foundation, but we do not know if some other deeper physics is acting as a support beam. The universe might not be a ticking time bomb after all. Or it might be, and the silent, expanding wave of annihilation is already on its way. We can only continue to exist moment by moment in the fragile, beautiful, and perhaps temporary reality we call home.